Thanks for watching this 11th video in a series of work solutions for Edexcel GCSE Computer Science. So in this video we're going to go through how to get to the answers for question 4a, which is about RAM and cache, and then we're going to introduce the keywords and the concepts for question 4b. So let's have another look at question 4a. So remember, you can download this past paper with a link in the description. So this says, describe one similarity between cache and RAM, and 2 marks available here. So in the previous video I said you had to both state and describe. So state means you make a point, and describe means you have to say how that relates to what the question says. So you only have to say one of these bullet points, but you have to make both of the points that are indicated with a little 1 here. So for example, if we're looking for a similarity between cache and RAM, you only need to say one of these bullet points. So they are both volatile, 1 mark, which means that anything stored in them is lost when you switch the computer off. That would get you full marks here. So you can pause at this point or skip to the end when we have a look at the next question, but it's probably worth talking about what RAM and cache actually are. So this diagram shows that the way humans work, you think in your brain and then you can remember certain key facts. Now my memory's appalling, I'm forever forgetting people's name, and I'm sorry if I've ever forgotten anybody's name who's listening to this video, but there's certain key facts you can store in your brain, but not many. So the key facts you can remember in your brain are like registers. They're very, very fast, but they don't store much. Then inside your CPU, you've got different levels of cache. Level 1 cache is the fastest, but stores the least. Level 3 cache is the slowest, but doesn't store that much. Think about it like when you're revising certain things. Obviously, you're not allowed to do this in exam, but you can fit a certain amount of information on the back of your hand, which is fast to look at, but doesn't store much. And the rest, you're probably going to have to put on flashcards or post-it notes. So the back of your hand's like level 1 cache, and a post-it note is like level 3 cache. Then the rest of your revision notes is stored in your exercise books, or however you've laid out your revision notes. That's like RAM. It's a lot slower than just trying to recall it from your brain. It can store quite a lot, but it's still an awful lot faster than traipsing down to the library and trying to get a textbook out from a classroom or something like that. So if you have to do that when you're revising, it takes you ages to get to the resource centre or the library or whatever you want to call it. That's like retrieving something from a hard disk. A hard disk stores loads, but it's very, very slow in terms of a computer to be both read and write. Then, if you think about, maybe there's an expert at a university in, I don't know, MIT in America or something like that. If you really want to find out loads of information, you can travel to the other side of the Atlantic, go and find an expert, or go to the other side of the universe if you want to try and find everything you know. That's like reading or writing to a backup drive. So you don't need to remember these numbers, but just in case you're interested, a register can read or write every time the clock tick happens. So a CPU, remember, is driven by a clock tick. It's like, my analogy is a slave driver beating a drum for all of the slaves inside a boat to row their oars. So every time a slave driver bashes a drum, all of the slaves on board have to pull their oars. So that's like the clock tick inside a CPU. Every time the clock ticks, which just means you have like a binary 0 changing to a 1, you can read or write from a register. But if you want to read or write from RAM, it's not exactly 100, but round about 100 clock ticks to be able to read or write from your RAM. So that's like the slave driver having to wait 100 times of bashing the drum before the slaves pull on the oars once. So RAM is slow. Then, in terms of clock ticks, a hard disk might be 1,000,000 clock ticks. So the CPU is sitting around waiting for absolutely ages before it can read or write to a hard disk. And then we're talking 1 billion-ish clock ticks to read or write from a backup drive. So how does RAM work? Well, the stuff in RAM that you need most of, so both data and instructions, data is like your variables, your personal data, and instructions is like the program code. All of the programs you're currently running should be in RAM, not hard disk. But then if you read or write frequently, if you need to access it a lot, you're going to store it in cache. So cache is just a small part of memory storage that you use frequently, And if you can't find what you need in cache, then you have to wait a little bit longer to try and find it from RAM instead. Okay, so sorry to go off on one, but I thought it's probably helpful to try and explain what RAM and cache are. Let's go back to the other options that you could have had for this question. So similarities between cache and RAM. They can both store both data and instructions in different locations. So a location, think of like an Amazon delivery driver. They need to know both what to deliver, that's the data, and where to deliver it, that's the address. So inside your RAM and your cache, you can store data in different locations. Both are slower than registers. Remember, registers are really fast storage, so the CPU has to wait a lot longer compared to registers to fetch or write data or instructions. Both RAM and cache are faster than a hard disk or a solid state drive, so the data instructions can be stored for the current program. Remember, you might have lots of programs installed on your computer, so you might have, I don't know, PowerPoint and Excel and Word all installed on your computer. They'd be saved on your hard disk, but only the ones that you're currently using would be loaded from your hard disk into RAM because it's much faster. Both have less capacity, so RAM and cache can both store less than hard disk or solid state drive. So you only store the programs you're currently using. And both have more capacity than registers. So registers only store a single value, but RAM and cache can store a lot more. So more instructions or more data. So that's the similarities. In terms of differences, same idea. You could say any one of these bullet points as long as you make a statement and then you explain that, you describe that statement a little bit more. So cache is faster than RAM, so the CPU doesn't have to wait quite as long to read or write from it. Or you could say the same thing the other way around. RAM is slower than cache, so the CPU has to wait a little bit longer if you have to read or write from RAM instead. Cache doesn't store quite as much, so it can't store as many items of data or as many instructions. Or the same thing the other way around. RAM has a high capacity, it can store more data or more instructions. Or you could say cache is directly connected to the CPU, whereas RAM is connected via cache. So the CPU will always try and read data or instructions from cache first, but if it can't find it there, because there's not that much space to store it, it then has to go and look in RAM instead. It's exactly the same as you when you're revising. You'll have a look on your post-it notes and flashcards first. If you can't see it there, then you have to resort to your exercise book instead. Okay, so we're going to also introduce the keywords and concepts for question 4b, and you need to sort these from the fastest to the slowest. So that's where the diagram that featured when I went off on one to talk about the difference between all the different types of storage, registers, hard disks, cache, and all of that. You just need to say the fastest is a number 1 and the slowest is a number 5.